Yeah, Muse, we don't allow incoherent nonsense or strawmans to be representing our community. We work on empiricism, logic, and so we test the claims. We don't just believe the claims. That's your side. Remember that.
We're more than happy to unmute you if you're willing to engage in a proper conversation. But don't be disparaging and don't come at this like a bigot.
And don't pretend you're one of us and don't try to speak for us. Just speak for yourself.
Yeah, that clown wheel crap, leave it at the door.
What was this experiment that you did, Indio, that the last people were talking about?
No experiments.
What?
So what Indio did, you can just scroll up. I'll give you the timestamp, and you can have a look at what he did.
What? I'm here. What's the question?
What was the experiment?
You want to know what experiment you did, Indio? I said it was not an experiment.
Yeah, I didn't do any experiments, man.
Then what were you guys talking about?
Observations and measurements. Those aren't really experiments. Experiments are for natural phenomenon. And they determine cause and effect relationships. So just measuring something, like if you went to the doctor and they measured your height, that wouldn't be an experiment, right?
True.
Yeah, so we're just doing measurements. That's it. We're measuring to see if the Earth. Measuring the distance of the horizon.
Okay, cool.
And to see if it matches the globe prediction, which it does not.
So where is that?
According to the globe mathematics, from my observation height of 15 feet, it should have been 4 miles away.
No. I'm asking where's all the data, I guess. I don't know. The video, did you make it?
Yeah, you can scroll up. It's in the side chat.
Yeah, I just tagged it. It says here, and then just click the attachment.
Yeah, or you can go to our home server and scroll down. There's A to C, a ton of data for you to go through.
Yeah, but this particular one is in the side chat. Obviously, this isn't the only thing we have.
You need to charge your phone, Indio.
Why is that?
You're at 8%.
What's wrong with my phone? Oh, well, it was, it was freezing out, man. It was killing my battery. I mean, it seemed like 40 degrees marinetraffic.com, yeah.
What is that? Is this talking about boats or something?
It tracks the boat position.
Position of boats, okay.
Yeah, so this particular position, hold on 1 sec. These particular positions, when they're in Boston Harbor, their position is given by a radar station in a place called Gloucester, Massachusetts. There's a radar station that tracks all the boats that are out there.
And then the second picture, what is this from, like Google Maps or something?
Yes, the red circle is where the horizon. The red circle is where the horizon should be, and the line is in the pin is where the boat was, according to the coordinate in the aforementioned image. So there's a coordinate in that marine traffic image, and that's the coordinate position in the pin.
Gotcha. And then that's the position of your camera, 10 feet above sea level.
15 feet, yes.
Or sorry, 15 feet. And then what's the next one?
That's a buoy that took the temperature data that's in the line of sight in the video that's further down. That's a USGS water buoy, or NOAA water buoy. So it measures the air and water temperature every 8 minutes or something.
Okay. Where does that one picture show the position, or say the position of the buoy?
The Google Maps?
No. In I guess the fourth picture, one of the weather buoy, the temperature one.
Yeah, that shows the air and water temperature.
Right, but you said you saw it in the video.
Yeah, the actual buoy.
How do you look at its position?
It's right in the line of sight. It's right in front of the boat.
I know, but how did you determine how far away it was?
I don't need to know the distance of the buoy.
Okay.
The buoy's unimportant. I only got the picture of the buoy because of the air and water temperature.
Okay, guys.
It was just a coincidence that it was in the line of sight.
Okay, sorry. I thought you were. Okay. Heard. Yeah, I got air temperature, water temperature. Okay, cool.
Yes.
And so you were tracking this to try and figure out the conditions of the air around above the sea, right?
Yeah, so I planned this for like 2 months. Well, I was looking for 2 months for a day where the air and water temperature were the same to go do an observation, or nearly the same.
Is your video in black and white, or is this?
It's infrared.
Oh, infrared. Okay, cool. Yeah, so I see 3 objects, or sorry, 4, I guess.
Yeah, 2 of those are lane markers and one's a buoy. So there's a shipping lane that crosses this. It goes left to right across the screen. And they have lane markers. So there's the buoy and the 2 lane markers.
Crap, you're seeing even more than you should see.
So you're saying at 3 p.m. you were able to, is when you took the video at 3 p.m.?
It's between 3 and 3:15, somewhere in that section. Because when I finished, I took a picture of a clock, which is further down. Clock that's right there on Revere Beach. Which is coming quite fucking useful for some reason. How do we know you were there at that time? Yeah.
I've really never heard any Globers ask these same questions about their own pictures, though. That's weird.
Yeah, I know. Here's and that, like, like the blue marble, the 72 blue marble, it's actually a dispute within Apollo, moon landing nerds, when that picture was actually taken, because they can't figure it out from the transcript when it was taken, because they never indicated it. They got transcripts of like what they're saying inside their little studio. I mean, on their way to the moon. Yeah, so it's a dispute among Apollo enthusiasts. The timing of that picture. So yeah, they do dispute it sometimes. Now, the key thing about me getting the air and water temperature the same is that any refraction effects that they say exist have to be minimal. So I did everything possible to minimize any effects of refraction, if there is such a thing, doing anything, by using A, infrared, and B, doing it at a time when the air or water temperature was nearly the same.
What do you mean if there is such a thing as refraction?
If there is such a terrestrial refraction, that's what I'm talking about. That the specific terrestrial refraction that they say bends light around a ball. That is horseshit.
I don't think people make the distinction between refraction and terrestrial refraction, but I see what you're saying.
Well, that's because that distinction doesn't fit the propaganda rhetoric that they do. Because if you say there's no refraction in these observations, they go, you don't believe in refraction? Now, there is a general phenomenon called refraction, but that's not what this is, okay? What they're saying is a specific type of refraction, specific condition that creates it. i.e., there's a density gradient that's curved. And because there's a curved density gradient, when light passes through it, it automatically curves around the ball, making the ball look flat.
Well, that density gradient it would be the air.
Except those density layers are flat.
Yeah, but it has to be a curved density gradient.
Is that right?
Yeah.
So light passing through 2 different mediums of different density, even if they're
There's only one medium, dude.
Yeah, but we're talking one medium. We're talking about air.
I know, but medium of a different density and temperature, doesn't that change it?
Well, what you're claiming
water,
is
like
that,
if you, so I know what you're saying. If you go from air,
but density is like, but density. Okay, let's break this down real quick. People use the word density, but that's technically wrong. It's the temperature gradient that causes the refractive effects, not the density gradient. in Maxwell's equations, which determine the refractive index of something, there is no density formulas. There is no density calculations calculating the density of the medium. Why is that?
In
When the
Maxwell's
speed of light
equations?
in Maxwell's equations of electricity and magnetism, because light is electromagnetic, right? Propagation.
Yeah.
Okay. So depending on the medium it passes through, that alters the speed at which light propagates. So when it goes through one medium where it's traveling at one velocity, and when it enters another medium where it travels at a different velocity, the light will be displaced. It'll be deflected. Okay, this
Right.
is what refraction it technically is. But
Correct.
the properties of these mediums is not based upon density. It's based upon the electrical properties. The technical terms are electrical permittivity and magnetic permeability, and that is how much that medium, when the light goes into it, its electromagnetic wave, how much it polarizes electrically or creates a magnetic field, how strong a magnetic field it creates at the same time, and then there's a resulting field that's created from that interaction, and that's what determines the refractive index of the medium. It's not the actual density, because in fact, there's turpentine, for instance. When it gets denser, its refractive index goes in the wrong direction. Doesn't
Right, so
increase, it decreases.
Uh-huh.
Because it's
So-
electrical, because it's the electrical properties. It has nothing to do with the matter per unit volume. Because density is matter per unit volume, right? It has nothing to do with matter per unit volume. It only has to do with the electromagnetic interactions of the molecules and atoms themselves. In temperature is the one that affects that the most. In fact, it's something like 4,000 times greater than changes in the density. And this isn't my opinion. This is in Understanding Astronomical Refraction by Andrew Thomas Young. You can go read it in there.
So I'm not like super up to date with Snell's law, but I know
They
that
don't.
the issue that we're having right now is about refractive indexes and how those are calculated.
Well, this would be a gradient refracted medium. This wouldn't be Snell's law because there's no well-defined boundary with two different refracting mediums.
Can't use
Snell's
the
law is
differential
not
version of Snell's.
What is that? Never even heard it or that. The differential
you-
version. They use the principle of least time. That's what they use.
So like if we're talking
Well-
about the same medium,
And they're not equivalent. Snell's law is not equivalent with that.
so you're saying it's not Snell's law that's in play here when you're talking
You
about light
can't use
bending
that. It's not equivalent to it. You don't. So there's two ways to do this. You can use Fermat's principle and the principle of least time. If you wanted, and you could use that in Snell's law is the special, what's called a special case of that. Meaning there's two mediums with a well-defined boundary between them. So using the principle of least time, you can get Snell's law to spit out. But you can't use Snell's law to get the principle of least time. It doesn't work the other way.
Get the principle of what time?
The principle of least time.
Principle of least time. Okay.
Yeah.
So Fermat's principle.
So electromagnetic radiation will take the path that it spends the least amount of time in the medium.
Right. And then,
That's why they call it the principle of least time.
and I guess so. Like I think when we're talking about refraction in the atmosphere, I know you guys don't like the term or sphere. Sorry, atmosphere or in the air above the water, is that there are different temperatures and possibly of different densities. So that's why the air refracts. And you're saying you can't use this because they.
No, I'm saying that there's no experimental evidence.
You can't take
What
the
I'm saying-
integral of like the air
You
density.
can do whatever calculate. Look, brother. You can do whatever fucking calculation you want. You can come up with any model you want. Eventually, no matter what, you have to test that against reality and actually get the validation of the model in reality, in the natural world, right? That's how you verify models. There's no model that exists which can accurately predict anything when it comes to this. Because there would be, if it was a deterministic model, that means that I could take a photograph and if I knew all the geometric particulars of the photograph, I could tell you the weather that day. You understand? Because then I could get out the air density. I could get out the humidity. I could get out by reversing it, right? Like, oh, look, man,
Photograph?
the ship is, well, you'd be able to reverse it, right? So you would predict the refraction, how much refraction, like say there's a boat out there and the boat's supposed to be sunk down 6 feet and it's picked up 10 feet instead. I go, okay, I can do a calculation to figure out how much refraction would have to exist for the boat to be displaced that much, right?
I think that's what I'm
But
trying to say is that you.
But that should be a reversible process where I can look
From
at
a
something else.
photograph.
The boat, like, hold on, dude. There should be a reversible process where I can look at the boat and get the meteorological conditions to spit out.
From looking at the boat?
Yeah, from looking at the boat. If it's a deterministic model, it should be reversible.
Even if the model is deterministic, just from looking at a photograph, you don't have all the variables. I don't believe.
What variables am I missing?
The temperature of the air between.
No,
you
I
and the
should be able to
boat.
predict the temperature that it was based upon the photograph.
How?
Because say the camera is the same height as the center of the boat. And then when I take the photograph, I know geometrically that's where it is. Then I take the photograph and the boat looks like it's 5 feet higher.
Oh, I see what you're saying.
I should be able to spit out the meteorological conditions that would cause the boat to look 5 feet higher.
I see what you're
If
saying.
it was an accurate deterministic model.
I believe
but
what-
there isn't one.
Yeah. No. I get what you're saying, and I think that's almost correct. But the amount of calculation you would have to do, because you have
Then
to
how
take
can
an
you-
integral between the air densities between you and the boat, right? Because you had to between the
They
distance.
use the calculus of variations is what they usually do.
Because again, if we're just taking the simplistic Snell's law, I guess the refractive.
You can't use Snell's law, man. I just told you that. I'm
I
gonna
know you
I'm gonna
did,
post
but
in the
like-
side chat a paper that demonstrates mathematically Snell's law and Fermat's principle and a gradient index medium are not equivalent. Okay, I'll just post the
Okay.
paper.
Well, obviously, should probably look into this more because I don't.
He doesn't.
The whole
No,
point
when I
is
talk about
the whole
refract-
point is this is all academic. You know, we can see, like I said, we can sit here and talk about models all day and argue about ultimately whatever concept you come up with, it has to be proven by experiment. And I challenge you to find any academic paper that accurately predicts the refractive index from the meteorological conditions by running it through a model. Right? That they take the meteorological conditions, run it through the model, and then their prediction of what they survey, look at, whatever, matches their prediction. It can't be done. It's never been done. And it says all through the academic literature that it's fucking mysterious and they can't figure it out.
I mean, I agree with you, but I just think the calculations would be astronomical that not even a fucking supercomputer could do it within our lifetime. Is why.
Yeah, but
I don't
so what
think
am I
it's
supposed to
because
say when people go,
think it's
you don't
because the
believe in
law is wrong."
refraction?
No, that's not
When
what
it-
I'm saying. You're asking for something that is, I don't know,
They say,
unreasonable.
but brother, I'm not asking
You're
for
trying
it.
to
They
ask
say,
me for the whole what the temperature is between all of the air in between you and the picture you just took due to the refractive index.
but they say
not-
that they can do that.
Who said that?
Dude, listen, if they
Who's
have
they?
a model, look, it will be just as complicated in either direction. Whether you get the at either end of the
What does that mean?
prediction, at the input
Complicated in
and the
either
output.
direction?
Okay, so you have an input and an output in the model in the middle. Okay? Got it? Understand? Input, output, model in the middle. Now your inputs could be the geometry or your inputs can be the meteorological condition. So if your input's the geometry, the meteorological conditions should spit out. And if your input's the meteorological conditions, the geometry should spit out. They say that they can do the meteorological condition input and spit out the geometry that should be seen.
Okay, who is they and where can I find it?
Walter Bislin, there's one.
Who the fuck is that? Walter who?
This is all over the place. I mean, I don't even know where to start. Every anti-flat earther in the world says that the globe, all the observations that we do, such as the ones that were posted in the chat, match the globe prediction.
Walter
Whatever
Bislin,
that is.
you're
And
at
that globe
Flat Earth
prediction is,
model?
well, hold on. And the globe prediction is I have a bunch of refraction sliders and I can alter and I can use a computer program with 3D elements in it, and I can move the refraction sliders until that matches the observation. And then they'll say that that movement of the sliders is a globe prediction of the observation. They say this all the time. This isn't new.
Right. So they changed the variables of a model to try and reflect reality.
Well, they just changed the. No. So say I have an image, right? I have an image. There's mountains. They're 100 miles away, and they shouldn't be seen. So what they'll do is they'll put in the geometry into this little 3D program. It's called Walter Bislin's Advanced Curve Calculator. They'll put in the dimensions, right? 15, I'm 1,000 feet tall. I'm 1,000 feet elevation. The mountain's 100 miles away. It's got 9,000 foot elevation, and it should, the horizon should be, and somewhere in front of it, the mountain should be cut off, 1,000 meters. And they'll say, okay, that's possible because I went into this computer program and I moved this refraction slider and increased the refraction in the slider using the model, using the refraction model. You just keep adding, you just keep changing the temperature gradient, right? You just maximize the temperature gradient until poof comes out, spits out, hey man, I made a prediction that matches the globe. That the globe predicts that that's possible. Well, none of these are actually predictions, they're all postdictions, right? But the point is that we've argued about refraction for a long time. I have, going on fucking 10 years now.
Oh no,
and there hasn't been a single fucking iota of evidence that any fucking model, like when people say, hey dude, this can happen on a globe because of refraction. And I go, okay, you think refraction exists and can make that happen. Justify that. Justify it in some way, any way, shape, or form. And they'll just talk in generalized platitudes about sugar water and all sorts of nonsense instead of actually saying, okay, they did these experimental, they did these experiments in this place, and they took a theodolite and they carefully measured displacements and they carefully measured the meteorological conditions. And this model, if you put the meteorological conditions in this model, it matches the displacements that they measured. So we know this model accurately makes predictions about, there's none of that. That doesn't exist. It's just claimed that it exists, but it doesn't actually exist.
I think you want it, so these models that are created, I think you want these models to be able to explain something that
models don't explain things, dude. If you're going to claim that refraction explains it, you need to have a justification for that exists in the natural world. You need something. Just saying that you can conceptualize a magic condition. I mean, gravity could explain it too. I can explain it with gravity. There's a fucking black hole at the center of the Earth that's fucking bending the fucking light around the black hole, such that it makes the globe look flat or something. Like I could also say magic. I could also say elves. I can explain it in all sorts of ways. That doesn't mean it has any validity or justification.
True. I just wanted to say that I think I don't think if I was trying to prove the Earth was a globe that I would use a model of refractive index to try and prove that. Do you get what I'm saying? So
no, they use it to say that all our observations don't mean any. All our observations also prove the globe. Yeah. So I mean, I don't know how familiar you are with what happens in this topic. So,
India, we've talked 100 times. How dare you? Okay. You send me your fake news stories every day almost.
You're talking about crit, bro.
Oh,
I'm not crit.
So sorry. Yeah, you're right. My bad.
Dude,
yeah,
wow.
dude, I should. You're lucky I can't come through the screen right now, motherfucker.
I'm so sorry.
They're just so angry. They're so angry at us. They'll just say anything at this point.
Crit, why'd you change your name? Triggering Triangle? What the fuck is that?
The whole point is if you're going to claim. If you're going to claim something, you have to actually have a justification for it. So what is the justification for claiming refraction bends light around the ball? Or that it's even possible? Is there any demonstrations, experimental evidence? Has anybody actually taken a fucking curved surface and did something, constructed a lens, added fucking, I don't know, CO2 or any other thing, did it in water, or whatever and made a curved surface look flat. No one's ever done that. As far as refraction, has anyone ever measured the light to be curving around a curved surface, or that it's even possible? Use a hill, use whatever, use a fucking man-made surface. I don't care. Has anyone demonstrated it's possible at all? That's the thing. No one's even ever demonstrated that it's even possible to do this.
So
It's only possible in some theoretical concept in someone's head.
So I haven't looked, but I can almost guarantee you that somebody probably has.
No,
You
they haven't.
Looked, you're stupid.
And
I can't provide you that information, so I'm not going to claim that. I just want to put it.
well, this is what we call the magic science guy fallacy. You think out there's some magic science guy that did the experiment. You don't know what he did. You don't know how he did it, but you know he must be out there somewhere.
I think it's an iteration on Snell's law.
Don't you think I looked?
Say that it can't.
Don't you think I looked? I've been looking for 10 years, dude. I've had every globalologist, physics, astrophysicist, PhDs, and you fucking name it, all come in our chats of the thousands of fucking people I've talked to, right? And specifically demanded the information, and not a single person has brought it. But you think somehow you're the guy that's going to go find the guy. You all think that. All of you. You think that somehow you know there's somebody out there with this information. Bro, I've read all the academic literature on this particular subject, terrestrial refraction, astronomical refraction, what is it, survey refraction, going back 150 years. And it all says the same thing. It is an intellectual mystery.
Okay. I believe. I don't think you're lying.
I could read you some citations, dude.
So, I mean, sure. Actually, yeah, that would be awesome.
Only if you're going to be a flat earther, he'll do that.
Fuck. Next time
Brad was
you guys
trying to
ask
get
me
paid.
for a citation, I'll tell you only if you become a round earther.
You don't have any citations, dude. We've been asking for globe citations for 13 years. You haven't shown us one thing yet.
This.
Crit, shouldn't you be looking for more fake articles to send
Look,
you?
guys.
What are you doing?
اللي بعده
Yeah, I put
Ask
out fake
question.
articles.
All right, hurry up.
Suck my ball.
Work on it, dude. I'm fiending for him.
انت بتاكله
Go on, you
Gay,
bitch.
motherfucker, gay.
It takes one to know one. Anyway, moving on.
Listen, I'm not
So-
saying you're wrong. I'm just saying
Look,
I feel like your expectations are.
Yeah, but I don't care about your feelings, dude. Your feelings don't matter. You're ignorant of the subject, and you're really just showing your bias. It's all you're doing. You have no information that I'm wrong in any way, shape, or form.
True. Very true.
Okay, but you
we're debating hypotheticals here.
No.
No.
no, we're not, because no one's ever observed this. You've never observed this. It's just some conceptual thing. It doesn't exist in any way except for in the minds of people. It doesn't exist out there in the natural world. You've never looked up. Imagine Napoleon's army is marching, and he gives away his position because it was refracted over a hill.
Again, I'm not saying the proof of there being a round Earth is due to the refractive index of light bending around a sphere. I think there's other proofs for that. You're just
No.
it's just
But
one.
that
of
one
the-
doesn't happen in the first place, so that's not a proof of among the other proofs. So you can't use that one.
Brother, this is like a straw man that is used so many
No,
times.
you're just ignorant. You don't
Over
know.
and
You just
over and
you
over.
just don't know that what you think are proofs actually aren't proofs. Just like you thought refraction was a proof for the globe, but we actually understand refraction far better than you. We
Okay.
argue with scientists on this, and we study this. So
Yeah,
we
so
know
are
that
you-
refraction
Oh, no
does
doubt you guys
actually
study
not
this.
help the globe at all, and it debunks it. And
Let-
so,
let me
if
read
you would
you,
like to jump to, if you would like to concede and jump to your next claim or what you believe is a proof, we can destroy that as well.
I don't have any claims, my friend.
Let me just read something. Variations in the refractive index in the atmosphere are caused by inhomogeneities of a wide range of sizes. These include both variations in the mean refractive index and refractive index fluctuations due to turbulence that cannot be accounted for by any deterministic model. I don't know how you can not be more clear than that. If temperature vertical profiles are unknown, then the refractive coefficient cannot be reliably determined.
Send me it is whatever you're reading.
The propagation path of light in the atmosphere is influenced by inhomogeneities of the refractive index. These refractive effects deteriorate the accuracy and direction and distance measurements. Not just the up and down, left and right, too. In geodetic applications, as illustrated by two examples in this report, the refractive effects cannot be accurately corrected. I mean, and on, dude. As in geodetic leveling, the atmospheric refraction can be the main source of error in the trigonometric method.
Sure, yes, because the atmospheric conditions are likely unknown. That's why
Okay.
it can be a source of it can be
That means they're not predictable.
variable.
Yeah, that means
Not that they're not predictable, but that they're not known. There are unknown variables. I mean, if you had temperature sensors set up, this is how you could do an experiment. I mean, if you had a controlled environment.
Okay, so you're going to mention an experiment that was already done, and then I'm going to tell you about it. So you think people haven't tested this shit? It's been tested, dude. It doesn't match prediction. What don't you get?
Then send me whatever this is, please. I beg you.
Okay, I'll give you a specific one where so when they did, it was in, yeah, I'll find it real quick.
Yeah, just send me whatever it is. Listen, dude, I'm honestly not trying to fucking argue.
I don't know why you're defending an idea that you literally have no evidence is true. That's what I don't get.
All I'm defending is your claims of there not being any evidence of it. I don't know.
do you have any evidence? What do you mean my claims that you don't know of any evidence? I'm claiming what you don't know exists actually does not exist.
Fair enough. Send me what you're gonna send me. We'll look it up. We'll check it out.
This is a particularly good one. It's called Influence of Atmospheric Refraction on Terrestrial Laser Scanning at Long Ranges, proceeding of the 4th Joint International Symposium on Deformation Monitoring. So they're highly accurately measuring deformations of landslides, right? Has that landslide moved? Because they want to predict whether it's going to, fall on a town or something. Okay. Hold on, I almost got it. There's one more thing I need. This. So these were measured. These actually measured the angle of arrival of two lasers. Okay, so I'm going to post in the chat. Can we still hear me? Test.
Yep, gotcha.
All right. So this graph. Okay, so here it says forward correction. Right. So what they did was they monitored this landslide continuously for 48 hours. This is 1 day of measurement. Now, the globe Earth quote unquote refraction prediction is that the deflection of the laser due to refraction would have been something about, I think it's 8 meters over this distance. Picked up, right, around the curve of the Earth. But according to what they measured, even at the maximum, it's 8 inches, not 8 meters. And the maximum is only at noon, as you can see, right? When it's at peak solar radiation and peak temperature, right? So the point is that this experimental result doesn't match any model. And I can post another one. He's still here, or did he bail?
I'm here, brother. I'm trying to
Okay.
read your fucking paper. So wait, did you give me a paper that you said doesn't agree with experimental models? Is that what this
Yeah,
paper
it doesn't.
is?
With their measurements don't agree with any model because the measurements of the quote unquote refraction in this measure the deflection of about 0.0036 degrees.
And it didn't match with whose other measurement.
The prediction, the deflection angle should have been like an order of magnitude greater than that if the current refraction models are correct.
Okay. From what they predicted. So their
No. From
measurements-
what their data shows. See, there's data and then there's the prediction. The data don't match the prediction. You guys are fucked up. You Go-Earthers are fucked up. No, you Go-Earthers are fucked up. You think the story is what happens in reality. No, you have reality, and then you have the story, and then you see if reality matches the story, and if it doesn't, then the story's wrong. What I'm showing you is reality doesn't match the story.
Why are you
You
getting
understand?
just asking a question, dude? I was just asking you questions. Relax.
No. You're asking me questions starting from the same starting point of the story's correct. No, fuck the story. It doesn't matter what they say. We have data. The data is what determines everything. It doesn't matter what people say about it. Only matters what the data shows.
Yeah, I'm
this
asking
data
questions
shows
from the worldview that I have, just like you are. You believe the fucking Earth is flat.
this is different than the goal prediction by an order of magnitude. An order of magnitude's too small at its worst.
Dude, let me read your fucking paper before you want me to argue about it. Holy shit, dude! Don't get so upset. It's fine. I'm just
Yeah, you can
talking.
you can mute yourself and go read the paper. That's fine. We can talk to somebody else.
Okay, I'd love to.
All right. See you later.
At least he'll be a flat earther after this.
It's always the same. We provide the evidence, we back up what we're saying. They can't provide any proofs of the globe.
Yeah, like cognitive dissonance is strong.
Yeah, like you're not bad to talk to because at least you can say most of the time when you don't know that you don't know. You know, we get people through here all the time that they will never say that they don't know. They'll just make something else up. Oh, it's this or it's this. At least you say you don't know. But you still argue that you do know, right? You argue like you know, but you say you don't know.
I do like to argue.
You can tell. It's more like a passive arguing, though, isn't it? It's like pretending to ask a question to see what answer you get that you think you already know the answer to, and then you argue the answer you get.
Yeah, I'm just trying to probe, what you guys believe, my beliefs, and see how they do.
Do you probe the globe side if you're not making any claims? Do you ever probe them? Okay, what questions do you ask them?
What questions do I ask the globe?
Yeah.
Well, mainly I try to verify the claims of the measurements of like the distance to the horizon, because that is like the majority of your guys' claim. That's basically the only thing you guys have is truly that like the measurements from the horizon don't make sense on a globe.
That's nonsense, man.
We go into refraction and shit like that every time.
Goodness.
So
why do we bring up the distance to the horizon? Why is that important?
Because that's the really only thing that makes sense. That
why is it important?
Into your,
why is it important though?
Because it's the only like physical kind of evidence you guys can produce, I guess.
It's not our evidence. We don't use it as our evidence.
Sorry, measurement, I guess.
Okay, listen. The horizon is you guys' evidence. Ships go over the
Yeah,
horizon. The sun sets behind the horizon. All that shit. Did you forget?
Thought we were
That all
talking
that
about
proves the globe. Remember?
he's already forgotten. He claims to have no arguments or claims anymore.
brother. I am lost. I got it. Gotta be
Okay.
honest.
Okay. So the globe claim is that the horizon is created by the edge of the ball, and that ships go over it, and the sun sets behind it, and the moon sets behind it, because it's physical.
The
It's the
moon
physical
or
edge of
the
a ball,
horizon?
right? You've never heard ships go over the horizon? And they're sailing over the
course,
curve of the
you know,
earth?
We were just talking about it, brother.
No,
Conan told me.
listen, don't, dude, don't. Have you ever heard of ships going over the horizon, and that is the curve of the earth?
Yes.
Okay. Now, if the horizon moves around, what does that mean for that claim? It can only be one of two things.
I don't know what you're asking me.
Either if I go out and the horizon at freaking 3 o'clock is 10 miles away, and then at 9 o'clock it was 8 miles away, and then at 11 o'clock it's 3 miles away, can that horizon be the edge of the ball?
No, the horizon is not a physical thing.
Okay, fine. That's why we bring it up, because there's still people in 2026 saying ships go over the horizon.
Yeah, the apparent horizon, I guess.
Yeah, so that means it's an optical illusion.
Yes.
Okay, so ships over the horizon or sunsets or any of that crap having to do with the horizon is not proof of a globe.
Okay.
Right?
Yeah, sure.
Yeah, sure. You'll still fucking argue it in 10 minutes. You're going to do the NPC reset and then fucking bring up ships over the horizon. Watch.
I'm already starting to forget. Just kidding, Indio.
I went down it. We bring that up. That isn't a flat Earth proof. We use the horizon to demonstrate that the globe geometry has to be wrong.
I get it.
Okay. Our proof are laser tests. Our proof is shit like that. So like a 36.7 mile fucking laser shot across the Bonneville salt flats. The perfectly symmetrical reflection at the Bolivian salt flats. That's our proof that the Earth is flat. Or just actually measuring the lack of curvature. Because just gawking at the horizon wouldn't prove a flat Earth. But they say it proves a globe. I mean, DJ was talking about last night. When I first entered this topic, they said that the very existence of a horizon was proof of a globe. It's the problem with you globe earthers. It's like you guys are just like whack-a-mole. You're trying to create an unfalsifiable condition. Oh, see the boat cut off halfway 10 miles away? Proof of a globe. See it cut off halfway 20 miles away? Proof of a globe. See it not cut off 30 miles away? That's also proof of a globe. Everything you see, proof of a globe. No matter what it is. Even if the observations contradict each other, still proof of a globe.
So look, again, I just want to point out, I wasn't trying to prove a globe Earth. I was just poking against
I'm not
specific
talking about you
things.
specifically. Don't personalize it. I'm just explaining to you why we bring up the horizon.
Okay, my bad. I thought you were talking to me.
You have decided you don't want to actually make any arguments.
No, I'm not trying to make any hard claims here. But when you talk about globe earthers and them having, you said that they're trying to make an unfalsifiable claim.
Yeah, they're trying to make their claim unfalsifiable.
Well, I'd argue that's what you are also doing.
Okay, in what way are we doing that?
Because you've made your claim of flat Earth almost unfalsifiable. What is the
How?
evidence that would make the Earth not flat?
Measured curvature. Measuring curvature of the Earth's surface. That's simple.
Without refraction?
What do you mean without? What does that mean?
As in, what kind of curvature, what kind of conditions?
That the surface of the Earth is physically curving.
How
physically.
would you make those conditions to be able to test that?
Well, you could shoot a laser.
Okay, is a laser not a form of light that would?
Yeah, it is.
Refraction.
Yeah, but there's no justification for the refraction, which we already covered. There's no justification for that. This is what I'm saying, is to make it unfalsifiable. This is exactly what I'm talking about. You literally did the thing I was just saying.
By asking you how you would test this?
By mentioning refraction, which there's no justification to bring up. Just like what if you said, you mean even that doesn't gravity affect light? What if your reasoning was, well, gravity bends light around the Earth? Would that be a justified caveat to that?
Is it a dependent variable? I don't know.
Let me ask you, would it be no, let me just hypothetically, dude, this is a hypothetical. Okay? I say, hey, you measure the curvature of the Earth. Well, how do you account for gravity bending the light? Would that actually be justified, or would you have to justify that in some way on using that and saying this is a variable that could confound the measurements? You'd have to justify it, right?
I believe so, yeah.
Okay, so the same thing with refraction. You need to justify it that it can confound the results in such a way that we can't measure the Earth. See, a confounding variable actually has to confound, okay? And if it isn't sufficient, say there is refraction, but what if the refraction is so slight that it's not enough to confound the measurements? Such as when the Lake Isomer laser test, when they shot the laser 41 kilometers, and the result was off the globe prediction by 2 orders of magnitude. And even if you take something like standard refraction, it's still off by 2 orders of magnitude.
So how do we determine if refraction plays a part in these measurements?
Well, that's not my problem.
Then what the fuck?
There's no evidence. There's no evidence that it does.
See, this is what I mean by Indio. You don't make any fucking claims. You don't give a shit.
No, because we don't listen. Yeah, we don't need to answer every possible imagined fucking thing in the head. You need evidence, right? So, like, this is called like the onus probandi. Okay, that you make a claim, then the burden of proof is on the person to prove the claim or show evidence for the claim. Okay, we don't have to proactively go search out every possible claim and find counter evidence to it even before it's said. We don't need to go find counter evidence for refraction. The burden of proof is on you to show that their refraction exists such that it can confound the results of a measurement.
See, this is what I mean by putting yourself in an unfalsifiable.
It is falsifiable. You go find the data that refraction can confound the results of the measurement, and then you're fine.
You brought up a laser measurement. You said what? 31 miles or something?
Yeah. So there's a 41 kilometer, 25 mile laser shot from 10 feet above the sea, like the lake. It's actually it used to be connected to the ocean. They cut it off, and they turned it into a saltwater lake.
What's it called?
Lake Isomer. It's in the Netherlands. It's IJSELLMEER or something. It's the Netherlands. They spell it weird. It's IJSELMEER. So,
The fuck do you put a J in that? Okay.
I don't know. I'm not IJ, so it's even weirder. So,
They did a laser measurement over 25 miles.
yes, they did
they-
a bunch of. They did a bunch of distances, and then they went back
They-
2 weeks. Then they went back three weeks later and did it again. They bought They brought weather stations, meteorological stations, and placed at both ends of the shot. Right, so they have the weather conditions. They replicated it. Okay, and the thing is, the result is 2 orders of magnitude different than the goal prediction. So the goal prediction is that the laser should have been 420 feet in the air at the other end, and it was 4 feet in the air.
Okay, I'm sorry. I'm trying to find this. Do you have the source for this, or I need to just Google?
Which? Isomer?
Yeah. Were we the ones talking about the influence of atmospheric refraction on terrestrial laser scanning at long range too?
Yeah. Yes, I'm the one who gave that to you.
Okay, I read some of that. We can talk about that.
Okay. What about the data? I don't give a shit what the people say, dude. I only care about what the data says. What did they measure? That's the only thing that matters.
The effect of the measurement object at the atmospheric refraction are linked, unavoidable, and cause apparent surface displacements up to a few decimeters.
Yeah, that's right. Decimeters. That's right. You guys need fucking meters. Multiple meters. So in the case of this one, that's the point. That is the point. Thank you for bringing that up. And the decimeter is and hold on, the decimeter is the distance measurement, by the way. So you kind of screwed up.
That was
because they're using the LiDAR also for distance measurement. So the distance measurement was off by a few decimeters.
They also carried out a numerical simulation. And the
Who cares?
simulation was off by a few decimeters too. I don't know. It's just.
Who cares? We can look at what the standard refraction predicts what it should be, and then we can look at what the data says, and they're not even close to each other. They're different by orders of magnitude.
Their simulation was only off by a few decimeters.
Simulation of what?
Of their perceived curvature, or the perceived the apparent ray versus the actual ray, and then there's a beta measurement between the actual ray and then the chord, which is the measurement between the same point from the actual ray and the chord, and then there's also the apparent ray. They did the experimental study and they modeled it, and it's also integral. It's an integral between the densities between the observer and the electromagnetic wave, or the point of the electromagnetic wave, and it's beta equals the negative of 1 to 0 of the partial derivative n over q L minus S over L ds. And so the measurement is not a linear equation; it's an integral, which I was saying.
Yeah, that's
earlier.
fantastic. Okay. But you have a measured deflection angle. The angle of arrival of the laser. So they bounce, they use 2 frequency LiDAR. They bounce each laser off, and then they can measure the difference in the angle of arrival to measure the refraction. So they have an angle of arrival. The angle of arrival is displaced by some amount, and then you can take that angle and extrapolate out. Right. So the displacement that was different, the difference in displacement was 0.00272 or 0.0036 degrees at maximum.
Mhm.
Okay, that's in the thousandths, right? 0.003 is in the thousandths, a thousandth of a degree displacement. Okay, so if you take a thousandth of a degree displacement and go, hey, 1 kilometer away, What is the distance of a thousandth of a degree displacement? It's like 8 inches. Okay? A kilometer away for the globe, the refraction is feet. Okay? It's multiple feet. So why the so-called standard refraction, if it existed, would be a confounding variable because it's large. The actual measured existing refraction that exists due to measurement that we know empirically is not large enough to confound any fucking measurement. This is what I'm talking about. What is the data? What's the justification? Not the justification based upon some concept, but the justification based upon empirical evidence.
I get you. Check.
Okay.
Check the.
Science is empirical. Hold on. I want to get clarified. Is science based upon empiricism? Is that the foundation of science, empiricism?
No, that's one of the references of the paper you posted.
No, is empiricism the foundation of science generally?
In a general sense, yes, I guess.
Yeah. In that if you don't have an experiment or an observation, you're not doing any type of science.
Right.
Okay.
Okay.
So the empirical observations and experiment control, okay? Not people's opinions about what should happen. It's what the data says. That's why I keep harping on this. What I found out about globe earthers is that you guys actually are not empiricists. You guys hate empiricism. You like explanations and storytelling time. Okay? You fucking hate looking at data. You hate looking at what the measurements actually show. You can't stand that shit. Okay? Because you like the stories, because it makes you feel better about the world. Well, there's
I'm an
a thing called
engineer, so I disagree. I like data. Big fan of data, actually.
Okay. Well, what am I supposed to do when they say there's X amount of refraction and all the textbooks say that and there's a bunch of people running around parroting, but when I go and look at the actual empirical data that's been accumulated over 100 years, none of it matches that crap. None of it. I'm not saying some of it matches and some of it doesn't. None of it matches. None.
I don't know, man.
Yeah, you can't believe it. How's that possible? Because if you go read the academic literature on refraction, you'll find out that none actually matches.
Yeah, you're right. I don't believe you. So, but that's okay. You
Look,
don't believe me either.
measurements of the
Anything I say.
variation of the vertical angle. 0.004 mgon. Okay? Gon is a measurement of angle that they use in surveying in Europe. Okay? Now you can convert gon into degrees. Now the max values here. These are the max, dude. Would be a displacement of 8 inches. Okay? At 25 miles. We have a measurement that's 2 orders of magnitude off, and the most, based on empirical data, that refraction could deflect it is a small amount. Now I could say, okay, let's multiply that by order of 10. Still not enough. In fact, I can take the standard refraction value on these measurements, and by the way, I posted the link in the chat. So I could take the standard refraction, the 76R. That would only move the laser down 5 meters. Now remember, I told you the predicted height, the globe predicted height of the laser is 420 meters. So let's subtract 5 meters. Okay, so what are we at now? 415 meters. Well, they measured the laser at 4 meters. How much refraction does it take to move the laser down from 400 fucking meters to 4 meters? Okay, and if you do the calculation, this matches a globe of a 65,000 mile radius. Yeah, so if the globe was 65,000 mile radius, this would confirm that globe. Like I said, there's no justification for the refraction thing. There's no data that supports it. It's just a story. It's an ad hoc hypothesis used not to falsify the globe. And here's the most ironic, two ironic things that I've noticed about this. You want to know what the evidence for globe refraction is?
Sorry, I got a dip, brother.
Yeah, it's that the Earth looks flat. That's your evidence for globe refraction. The flatter it looks, the more refraction it is.
Roger.
And that's great evidence. Yeah, peace out.
All right.